Hello students, welcome to the last minute formula revision session. We will start with exact differential equation. We know that the format of the equation is mdx plus ndy equal to 0. This equation becomes exact differential equation if it satisfies the condition dou m upon dou y equal to dou n upon dou x. This is known as condition of exactness. If the given differential equation is exact, it has to satisfy this condition. Partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that this given differential equation is exact. And once we know that the given differential equation is exact, we can write its solution by using the formula integrate all the terms of m with respect to x, and in the second term of the solution integrate terms in n without x, right? What does it mean by without x? If any terms which contains x, no need to include here, right? So for example, here I have written n is equal to x square plus y square minus xy. So here in n, first is x square, don't take it, right? Second term purely y square. This is independent of x or free from x. So this term will come over here, right? Third term won't come. So only y square will come here. And most important, the RHS must be an arbitrary constant. So we have to write C. So the formula is integrate m into dx plus second term is integrate terms in n free from x or without x in with respect to y is equal to C. Now, if the given differential equation does not satisfy the condition of exactness, it means that dou m upon dou y is not equal to dou n upon dou x. Then the given differential is non-exact. So in this case, we have to find integrating factor. So there are some rules for finding integrating factor, and the given differential equation is non-exact, and if you multiply by integrating factor, it becomes exact, and the formula is C. So let us understand what are the rules for finding integrating factor. Rule number 1, which is homogeneous. If the given differential equation m dx plus n dy equal to 0 is a homogeneous differential equation, means degree of each term, if it is same, we are going to call it as homogeneous differential equation. Then the integrating factor is 1 upon mx plus ny. This is the integrating factor. Right. Now rule number 2. We know what is meant by homogeneous. I have explained in one line. If the degree is same, then the given differential equation is homogeneous. Rule number 2. We can see here in rule number 2, here the first function f1, that is xy, right? f1 xy into y dx plus f2 xy into x dy. Remember, they are the opposite variables. Y with dx and x with the dy is equal to c if the given differential equation is of the type this, right? Then the integrating factor is 1 upon mx minus ny. This is the integrating factor. Rule number 3. In rule number 3, we will find the difference dou m upon dou y minus dou n upon dou x, and if you divide it by n, it has to be a function of x, right? It has to be a function of x or constant, you can say that. In that case, integrating factor is e to the power integral f of x into dx. And the last rule number 4 for finding integrating factor is, now see the difference is dou n upon dou x minus dou m upon dou y divided by m, and if this difference is a function of y or a constant, we are going to call it as if we integrate it, it becomes an integrating factor. So if is equal to e to the power integral f of y into dy. So these are the four rules for finding integrating factor, right? Now we will move to the linear differential equation. We are going to call it as LDE, right? LDE. So when we say that the given differential equation is in this form, LDE, dy by dx plus py equal to q. This is the structure of the LDE, right? And the coefficient of dy by dx must be 1, remember here. The coefficient of dy by dx must be 1, and the RHS part, okay, the RHS part must be a function of x or constant. So before comparing or before writing p and q, we have to check all these conditions. And where you will see the p part, p is, it will, you can see in the second term, p will present in the second term. So if the given differential equation is LDE, here also we have to find integrating factor. Integrating factor is if is equal to e to the power integral p into dx, and the solution is dependent variable. Whatever is the dependent variable, we are going to write the dependent variable then into if is equal to integral q into if and dx here. Okay, so here if x is the independent variable, we will write dx. If the second form is there, or that we will see afterwards. Okay, sometimes you have to write dy also, but right now you can consider uh, dependent variable into if is equal to integral q into if into dx. Then the Bernoulli's equation. We know that the Bernoulli's equation is dy by dx plus py is equal to q into y raised to n here. You will see here one term which is y raised to n, right? Then we have to divide, right? This is a y raised to n. In this way, we can say that the given differential equation is Bernoulli's, and we know the procedure. Okay. Okay, so this part, this we have discussed about the differential equation. Now quickly we will describe, or we will revise Euler's method. We know in Euler's method how, how to find xn, which is x0 plus nh, right? X0 plus nh, that will be xn. For example, if you want suppose x1 we want. So if you want x1, what to do here? Your x1 is equal to x0 plus h, right? If you want x2, that will be x1 plus, you know uh, x1 plus h here. If you want x3, you can write x2 plus h, or the same thing you can define like this. You can define like this in terms of n also. Suppose we want x1, we can write x0 plus h. If you want x2, you can write x0 plus 2h. If you want x3, you can write x0 plus 3h, and so on. In this way we can find x1, x2, x3, and so on. And in Euler's method, we have to find yn. So yn is equal to yn minus 1 plus h into f of xn minus 1, comma yn minus 1. Or you may, if you want, suppose y1 here, we can write y0 plus h into f of x0, comma y0. Clear? Here dy by dx is slope, which is f of x comma y, and they will give you the initial values. For example, y of 1 is equal to 2 is given. This implies that this 1 is x0 and this 2 is y0. This is known as initial condition. Now we will see Euler's modified method. In Euler's modified method, again the same formula for to find y1. To find the y1, we have to use the same formula given by Euler. Okay, so this is a Euler's method. We have to use Euler's method first, and then we have to use Euler's modified method. In Euler's modified method, we are going to take average of the slopes. which is, suppose y1 of n, this n is representing, first approximation, second approximation, and so on. So y0, which is the initial value, plus h by 2, and here we are going to write the slope, sum of the slopes here. Slope at x0, y0, and slope at x1, y1, we are going to add it, right? So the formula is y0 plus h by 2 f of x0 comma y0 plus f of x1 comma y1. Suppose if you want to write like this, y1 of 1 first approximation, which is y0 plus h by 2 and f of x0 comma y0 plus f of x1 comma y1, and here the value of y1 we can find using Euler's method, right? Here the value which is used we can find using Euler's method. Similarly, we can write for y1 of 2 also. And most important, all of you remember, if in the given question log is there, log to the base e, then in the calc we have to use ln, right? And if there is log to the base 10 is given in the question, we have to use log, right? So all of you, this is very important setting that you have to do in the calc. For log to the base e or simply log, we have to use ln, and log to the base 10, if it is given specially, we have to use log function of the calc. Then we will see fourth order Runge-Kutta method. Here we have to find k1, k2, k3 and k4. So let us revise how to find k1. K1 is equal to h into f of x0 comma y0. Once we know k1, we can find k2. K2 is h into f of x0 plus, here all of you remember h by 2 is there, comma is there. This is not the addition, remember, y0 plus k1 by 2. While calculating k3, this k2 value is used over here. Rest part is same in k2 and k3. Rest part is same. K4 is equal to h into f of x0 plus h, there is no divide by 2, remember, comma y0 plus k3. Once we know everything, k1, k2, k3 and k4, we have to find k. K is 1 by 6 times. K is 1 by 6 times, right, k1 plus twice k2 plus twice k3 plus k4. In this way we will get the value of k, and finally y equal to y0 plus k. In this way we can find the value of y at next value x1, which is equal to y1. Clear? So these are the formulae we have to use in RK method, or simply RK method of fourth order, right? Now we will revise higher order differential equation. First of all, we have to compare the given differential equation f of d into y is equal to capital X. This capital X is the RHS. We have to find its solution. We can find its solution by writing complementary function plus particular integral, right? Okay. Now, how? What are the steps? What are the steps to find the complementary function? If the roots of auxiliary equation are distinct and real numbers, suppose m1, m2, m3, then we have to take some constant c1, c2 and c3. c1 e raised to first root m1x plus c2 e raised to m2x plus c3 e raised to m3x. So this is the way of writing complementary function if all the given roots are distinct. Next is, suppose the roots are real and repeated. So I have considered here m1, which is distinct, but m2 and m3, they are real and repeated also. They are equal. So we can write c1 e raised to m1x. This is not repeated, but here root is repeated, m2 is repeated, so we can write c2 plus c3x e raised to m2x. Suppose the roots are imaginary and distinct. Suppose alpha plus I beta and alpha minus I beta. So here we have to write CF, corresponding CF is e raised to alpha x. This is a real root. Then C1 cos beta x plus C2 sin beta x. And the last case is, suppose the roots are imaginary है plus repeated है, imaginary and repeated. I have considered here only a root which is imaginary है and repeated है. So here e raised to alpha x, alpha is same, right? Beta is there, root is repeated, so we have to write c1 plus c2x cos beta x plus c3 plus c4 x sin beta x. Now we will see what are the steps for finding pi, which is particular integral. Suppose pi is equal to, how to find pi? This is 1 upon f of t into capital X. Capital X is RHS. If capital X is 0, then there is no need to find pi. We have to find CF, and CF is the final solution. Next, in suppose capital X is e raised to ax, right? Exponential function. Then we have to replace d by a. Okay, here in f of d, we will replace d by a simply. Okay, special case you have to remember. If this f of d is going to be 0, we have to write x in the numerator and differentiate denominator and then replace it. Okay, then replace it. This is the special case. Third, if the RHS is sin AX or cos AX, right? In this case, replace only d square term by minus of a square. Next case is, suppose it is x raised to m is there, x raised to m. First of all, we have to write in ascending order. We have to write in ascending order of d, and we have to express like this 1 plus here whatever it may be x, right? Or function of d sometimes, right? Or minus also here into here whatever function is given x raised to n, and we have to use the standard results of expansion. 1 plus x raised to minus 1 means 1 minus x plus x square minus x cube and so on. Keep alternate sign here, and if 1 minus x is there, 1 minus x raised to minus 1, if it is there, all are positive sign. 1 plus x square plus x cube and so on, all are positive. Next type is, suppose RHS is e raised to ax into v type here. So what we have to do in this type, we have to replace d by d plus a, right? We have to replace d by d plus a, and the rest is depend on v here, right? Whatever v is there, use that type of shortcut method to find the remaining part. And the next is x raised to m into v. Do not simplify this formula. Pi is equal to x minus 1 upon f of d into f dash of d, and outside this 1 upon f of d into v. Here I have explained in detail. Now the most important method is method of variation of parameters that we will discuss. In method of variation of parameter, these are the special cases that I have explained here. Some trigonometric formulae are there. I hope you are aware with this, right? Again, e raised to x into v is there. Same type I am explaining here. Replace d by d plus a and so on. And here suppose 1 plus d has come in the denominator, then you need to multiply 1 minus d and divide by also 1 minus d, and we have to do the remaining part here. Right, now we will this is a general method. We know that 1 upon d plus a into capital X is there, then e raised to minus ax inside the integral e raised to ax into this capital X into dx. This is a general method. Okay, now the most important, which is method of variation of parameter. In method of variation of parameter, first you need to find the CF, and we have to compare this CF with y is equal to C1 into y1 plus C2 into y2. From this we will get y1 and y2. Once we know the y1 and y2, right, we have to find w. We have to find w. What is w? W is a determinant. First row is y1 and y2, and second row is y1 dash and y2 dash, its respective derivatives. We know that we have to assume that u into y1 plus v into y2, and here we have to find u and v, right? Okay, this is same w. branch scale, we have to find it. So the formula to find u and v is u is equal to, remember here minus sign is there, minus integral y2 upon w into capital X into dx. V is equal to, here no need to write a plus sign, but remember there is no minus sign here. V is equal to integral y1 upon w into capital X into dx. And finally, y is equal to Cf plus Pi. In this way, definitely we can solve example by using method of variation of parameters. Let us quickly revise numerical integration. In numerical integration, there are three rules. First is trapezoidal rule. Integral from a to b, y into dx. This y is a function of x, right? Integral a to b, y into dx is equal to h by 2 x plus 2r. Remember, what is mean by x here? Extreme ordinates. Matlab y0 plus yn, right? Yn is the extreme ordinate. 2 times remaining y1 plus y2 and so on till yn minus 1. Sometimes we have to use, Simpson's 1/3 rule. For Simpson's 1/3 rule, it is important that this yn, this n has to be an even number. N has to be an even number. Then only we can use it. So h is equal to, in 99% examples, b minus a upon n, you can keep n as 6. If you keep n at 6, it will solve the problem of Simpson's 1/3 rule as well as Simpson's 3/8 rule also. So the formula for Simpson's 1/3 rule is integral a to b y into dx, which is common for all three rules. We are going to solve the integral by using Simpson's 1/3 rule. It is h by 3 x plus 2e plus 4o. Here e represents sum of even ordinates, matlab y2, y4 and so on, even, plus 4 times odd ordinates, matlab y1, y3 and so on. Okay. X is the meaning of x is same, extreme ordinate, right? Simpson's 3/8 rule. This is 3h upon 8, most important. In Simpson's 1/3 rule, h by 3. Here it is 3h by 8, right? And the formula is x, sum of extreme ordinates, plus 2 times t, means 2 times multiple of 3 here, matlab y3 and so on, right? And 3 times remaining values. So in this way, we can use Simpson's 3/8 rule. X is sum of extreme values, R is sum of remaining values, E is sum of even ordinates, O stands for sum of odd ordinates, and capital T sum of multiples of 3, right? Now quickly we will revise triple integration. All of you remember, in triple integration, first of all we have to see the limits of innermost integral. Remember, this is an example I have explained with the help of example. Here x and y, both the variables are there. It represents that these are the limits of z, okay, and we have to integrate with respect to z first. Okay, we have to integrate with respect to z first. So here we have to integrate with respect to z. Then here x is present, means they are the limits. Only two variables left now, x and y, because okay. So here x is present, means they are the limits of y. We have to integrate with respect to y, and finally we have to integrate with respect to z. So order must be integration with respect to z first, then y, and then x. Okay, these are some 12 standard simple formulae. I hope you are aware with all these formulae. Yes. Let us write, spherical polar coordinate here. So in spherical polar coordinate, remember, this is the equation of the sphere, x square plus y square plus z square equal to a square, right? A is the radius here. Suppose a is equal to, equation is x square plus y square plus z square equal to 2. It means that the radius of the sphere is root 2, remember. Okay, if it is given 2, then the value of a is root 2. like this. Radius may change in the example. So here we have to write x, y and z. How to remember x, y, z? Remember in all three cases this r part is there. Okay. Along with x, sine theta, sine and cosine, like this, sine and cosine. Okay. So here r sine theta into cos phi, y is equal to r sine theta into sine phi, and z is equal to r cos theta. And dx dy dz is equal to r square. Remember this is r square sine theta dr d theta d phi. So we know the limits here. Suppose x square plus y square plus z square equal to, suppose r square is given, means r is the radius of the sphere. R and a both are same in this case. So limits for first octant r varies from 0 to a, right? And theta varies from 0 to pi by 2 and phi varies from 0 to pi by 2. You can solve the given example by taking these limits if it is asked for first octant. And suppose you want for full sphere, you need to multiply it by 8, right? We have solved such examples in the class. Ellipsoid here, ellipsoid is again here, it is like a similar question here. X square upon a square plus y square upon b square plus z square upon c square equal to 1. So here you need to multiply with a, b and c, right? Whatever the coefficient, whatever the for sphere, whatever the value, spherical polar coordinate are there, same we have to write, we have to multiply by a, b, c. Along with x, a times, along with y, b times, along with z, c times. Remaining part is same here. And dx dy dz here abc r square sine theta dr d theta and d phi, right? And r is the radius of the ellipsoid. Again for first octant r is from 0 to 1 here, because see the equation here RHS is 1, so r varies from 0 to 1, theta 0 to pi by 2, phi is from 0 to pi by 2 for first octant. And if you want for full sphere, just you need to multiply by 8, right? Multiply by 8, right? Okay, now the next is beta and gamma function. This is the relation between beta and gamma function. Beta of m comma n is equal to gamma n into gamma n divided by gamma of m plus n. Suppose we want beta of 1 comma 1. So gamma 1 divided by gamma of 1 plus 1, which is 2. Gamma 1 is 0 factorial, gamma 1 is 0 factorial, gamma 2 is 1 factorial. And remember 0 factorial is not 0, it is 1. So answer is 1 here. Beta of 1 comma 1 is 1. Okay, this is we have used many times. Suppose gamma of n plus 1 is there, we can write is n factorial, or gamma of n is there, we can write n minus 1 factorial if it is a positive integer. For example, I want gamma of 7, we can write just a 6 factorial, right? Then this is the most important formula or one of the type of beta function, integral 0 to pi by 2. Remember, limit has to be 0 to pi by 2 sine raised to p theta, right? And this theta must be same, cos raised to q theta d theta is equal to 1 by 2 beta of, here whatever p is there, p plus 1 by whole divided by 2, whatever q is there, q plus 1 whole divided by 2. All of you remember, this is a very important formula. Remaining types are there, we have studied in detail in the class. Okay, so in this way, just how to identify the or tracing of curve, we can say that. Suppose y is equal to x and the linear power is there. We know that always this line passing through the origin, which is in first quadrant and third quadrant, right? And suppose x plus y is equal to 1. This is the line, so it intersects x-axis and y-axis at 1 comma 1. This distance is 1 and this distance is also 1, right? Circle, we know the standard equation of the circle and general equation of the circle. Then the ellipse, this is the structure of the ellipse, this is the structure of the hyperbola, parabola. There are four types of parabola. Y square is equal to 4x. This is C type curve, right here. This is the vertex. Y square is equal to minus 4x. This is again a C type, but this this is a negative. Here, our vertex is again 0, 0. X square is equal to 4ay. So here it is symmetric with y axis. All of you remember here. Vertex is again 0, 0 here. X square is equal to minus 4ay. This is again symmetric with negative y-axis. So these are the important curves, which is asteroid. Sometimes they may ask to find the length and all. So x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. This is the asteroid curve, and this distance is a here. Okay, this is a symmetric figure. Remaining are there. Just you can lemniscate. Lemniscate is also there. R square is equal to a square cos of 2 theta. This is like an infinity symbol. Cardioid. This is very, very important. Cardioid. So we know that cardioid. So generally, uh, we can write it like this, right? You can start from the origin. This is the equation for R is equal to a into 1 plus cos theta, and this is the equation for R is equal to a into 1 minus cos theta. Right, this is a cardioid. Rest you don't consider right now. There are many special cases here. Right. And DUI's rule. We know that differentiation under integral sign. Here we have to find the parameter. Selection of a parameter. Parameter is, other than the variable of integration. Sometimes it may be A, it may be alpha, it may be beta, or B, and so on. Okay, and so on. Then apply the DUI's rule. This is differentiation under integral sign. We have to differentiate with respect to the parameter first, then integrate with respect to the parameter, and to find the value of C, for one parameter we have to put, suppose alpha is a parameter, alpha equal to 0 to find the value of C. Suppose two parameters are there, alpha and beta, so equate them, alpha equal to beta, we will get the value of C here, right? Mostly they will ask example with respect to one parameter. And these are, basic formulae are there. Integration of x raised to n dx, x raised to n plus 1 upon n plus 1. This formula, second formula, which is highly used, f dash of x upon f of x is equal to log of f of x plus c here, if it is a indefinite integral. 1 upon x square plus a square, 1 by tan inverse x by a plus c. Then here 1 upon under root a square minus x square sine inverse x by a plus c. Derivative of log of f of x, 1 upon f of x into derivative of f of x, or sometimes you can write it as f dash of x also, 1 upon f of x into f dash of x. So a raised to x into log a, tan inverse of infinity, always you can remember pi by 2, and e raised to minus infinity is 0. These are the two formulae which is highly useful. E to the power ax into sine of bx dx. If sine is there, here negative sign is there, all of you remember, here it is a negative sign. E raised to ax, a square plus b square, a into sine bx, negative b into cos of bx. And if it is a cos, then positive sign is there. Okay, in this way you can remember. For sine, negative sign. For cos, it is positive sign. Derivative of e raised to f of x is e raised to f of x into f dash of x, and so on. These are the basic results. We know the partial fraction. Sometimes we have to use partial fraction also. This is again one of the basic formula, 1 upon integration of 1 upon root x dx is equal to 2 times root x, right? 2 times root x. Integration of 1 by x is equal to minus 1 by x square. Derivative of 1 by x is minus 1 upon x square. Okay, some special cases are there. Some special cases. Beta, gamma function. Lastly, the gamma function. In gamma function, all of you remember here, the limit must be 0 to infinity, and e to the power minus x. This term is most important in case of gamma function. So here, this is the definition: 0 to infinity, e raised to minus x, x raised to n into dx. So here we have to whatever here n is there, just you need to add n plus 1 power, right? Power में 1 add करना है. So this is regarding gamma function. Gamma of 3 is equal to 2 factorial and so on. This gamma 3 by 2, we have to use like this. Gamma of n plus 1 is equal to n into gamma n here. Suppose 3 by 2, 3 by 2 ke liye we can write 3 by 2 or 1 by 2 plus 1, 1 by 2 plus 1. Value of n is here 1 by 2, so 1 by 2 into gamma 1 by 2. And we know that gamma of 1 by 2 is root pi. Suppose 11 by 2 is there, you can start from reduce 2 from the numerator, 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, and it will end with the gamma of 1 by 2, right? So that the one more formula which is very useful, gamma p into gamma 1 minus p. Addition must be 1 here, then only we can use this result, okay? Addition is always 1, then only we can use this result, which is pi upon sine of p pi. P is between any value between 0 to 1. For example, here gamma 3 by 4 and gamma 1 by 4. You can see the addition 3 by 4 plus 1 by 4. Addition is always 1 here. If addition is 1, we can use here pi upon sine p. P is 1 by 4 here. 1 by 4. 1 by 4 is the value of the p. So pi upon 1 upon under root 2, which is equal to root 2 into pi. All of you just remember here examples on log, means log of e, right? If they write like this, you have to consider this as a log to the base e, and in the calci we have to use ln, and suppose log to the base 10, if it is given, then we have to use log function of the log calci, log function of the calci. Log of 1 is always 0 here, log of 0 is not defined, all of you remember. And suppose log of 1 by x has come, so we can write it as minus log x also, because this is required in certain types of gamma function. Okay, I hope these many formulae are enough. Last minute revision here. This is a beta function. Beta function, may all of you remember, integral from 0 to 1 x raised to m 1 minus x raised to n minus 1 into dx, which is beta of m plus 1 and n plus 1, right? Power may we have to add 1. Beta of m comma n and beta of n comma n value is same. Suppose beta of 2 by 3, 2 comma 3, and beta of 3 comma 2. This is same, commutative, we can say that. Relation between beta and gamma already we have explained, that is gamma m into gamma n divided by gamma of n plus m. This is the formula again. I am going to revise. 0 to pi by 2 sine raised to p cos raised to q theta d theta. Most important, don't forget here 1 by 2 is there. 1 by 2 into beta of p plus 1 by 2 comma q plus 1 by 2. These are the basic formula. Sine 2x you can write 2 sine x cos x and so on. Half angle formula. Sine x को you can write 2 sine x by 2 into cos of x by 2. 1 plus cos x के लिए 2 cos square x by 2 and remaining. UV rule, we know that integration by parts here, how to select u and v. U is first logarithmic, inverse function, algebraic, trigonometric and exponential function here. So this is the duplication formula. Gamma m into gamma m plus half divided by and gamma of 2m is equal to root pi upon 2 raised to 2m minus 1. So area के लिए we know the formula for area, which is one of the application of double integral. Area is equal to double integral dx dy, or you may write double integral dy dx. If your strip is vertical, we use this formula. If your strip in the given region is horizontal, we have to use first formula. In polar form, we know that area is equal to r into dr into d theta. In polar, we have to take radial strip which is starting from origin r, right? R equal to 0 to r equal to whatever is there. So these are the formulae we have revised for exam point of view. Students, all the best. You have